The Hubble Space Telescope gave us NZ11, a galaxy that formed roughly 400 million years after the Big Bang, a marvel that held the distance record for years. But Webb, with its infrared vision and unprecedented sensitivity, shattered that limit and handed us JADES-GS-z13-0, a galaxy that existed a mere 320 million years after the universe began, a blink of an eye in cosmic history. Let us start at the beginning, 13.8 billion years ago, when the Big Bang set everything in motion. In the first few minutes, the universe was a searing hot soup of particles, too dense and energetic for light to travel freely. As it expanded and cooled, protons and electrons merged to form neutral hydrogen, the simplest and most abundant element in the cosmos. This began the cosmic dark ages, a period where no stars or galaxies shone, where space was filled with a thick, opaque fog of neutral gas that swallowed all light. For hundreds of millions of years, this darkness ruled. Then, tiny fluctuations in the density of matter began to clump together, pulled by the invisible hand of dark matter. These clumps grew, gathering more gas, until the pressure and temperature at their cores became so intense that nuclear fusion ignited. The first stars were born, massive, hot, and short-lived, burning brighter than any stars we see today. These stars were the first sparks in the endless dark, and their collective light would soon form the first galaxies, including our extraordinary JADES-GS-z13-0. The discovery of JADES-GS-z13-0 is not just a find. It is a triumph of human ingenuity and international collaboration. This galaxy was uncovered during the JWST Advanced Deep Extragalactic Survey, known as JADES, an ambitious program designed to peer into the earliest corners of the universe. On September 29, 2022, Webb-S, near-infrared camera NIRCam, captured a faint red speck in the Goods South Field, a tiny patch of sky in the constellation Fornax that has been studied by telescopes for decades, including Hubble's ultra-deep field. At first glance, it looks like any other dim object, but astronomers noticed something remarkable. Its color was unlike anything they had seen before. In an expanding universe, light from distant objects gets stretched to longer, redder wavelengths, a phenomenon called cosmological redshift. The higher the redshift value, the farther away the object is, and the further back in time we are seeing it. For JADES-GS-z13-0, preliminary imaging suggested a redshift of nearly 13, a number that left the scientific community breathless. To confirm this game-changing number, the team used Webb's near-infrared spectrograph NIRSpec in October 2022 to capture the galaxy S spectrum, the fingerprint of its light. Spectroscopy is the gold standard of cosmic measurement. It eliminates all doubt and tells us exactly how far an object is. The results were definitive, a precise redshift of 13.2, making JADES-GS-z13-0 the oldest and most distant galaxy with confirmed spectroscopic evidence at that time. This means the light we detect from this galaxy left its surface 13.4 billion years ago, when the universe was less than 3% of its present age. And because the universe has continued expanding during that time, this galaxy is now roughly 33 billion light-years away from Earth, a mind-bending distance that reminds us how vast and dynamic our cosmos truly is. Let us paint a picture of what JADES-GS-z13-0 was like when it emitted that ancient light. It is a Lyman break galaxy, a type of early galaxy defined by its intense ultraviolet radiation from newborn stars. Unlike the grand structured spiral or elliptical galaxies we see today, such as our Milky Way, this ancient galaxy was small, compact, and chaotic. It was built almost entirely from hydrogen and helium, the primordial elements forged in the Big Bang. It contained almost no heavy metals, elements like carbon, oxygen, or iron that are created in the cores of later stars and scattered when stars die. This lack of metals tells us it is made of the very first generation of stars, population, 3 stars, which were vastly different from the Sunday. These stars were dozens of times more massive than our Sun, burned through their fuel in just a few million years, and died in spectacular supernovae that seeded the universe with the first heavy elements. JADES-GS-z13-0 was a factory of these cosmic pioneers, churning out stars at a rate that challenges our old models of how quickly galaxies could form in the early universe. One of the most profound mysteries JADES-GS-z13-0 helps us solve is the epoch of reionization. the cosmic transition that ended the Dark Ages. The neutral hydrogen fog that filled space absorbed ultraviolet light, keeping the universe dark. But the intense radiation from the first stars and galaxies, like JADES-GS-z13-0, stripped electrons from the hydrogen atoms, turning the neutral gas into ionized plasma. This process cleared the fog, making the universe transparent to light, and allowed radiation to travel freely across space for the first time. Before Webb, astronomers argued about when reionization began and how long it took. JADES-GS-z13-0 proves that massive star-forming galaxies existed just 320 million years after the Big Bang, early enough to drive this cosmic transformation. It tells us that the universe's first lights were brighter and more efficient than we thought, capable of ionizing huge volumes of space in a relatively short time. The story of JADES-GS-z13-0 is also a story of pushing the boundaries of what our technology can do. For years, Hubble was the king of deep space observation, but it operates mostly in visible and ultraviolet light, which gets stretched into infrared wavelengths by the time it reaches us from the earliest galaxies. Neutral hydrogen blocks visible light, making those ancient galaxies invisible to Hubble. Webb, however, is built for the infrared. Its giant golden primary mirror and sensitive instruments can detect these stretched, faint infrared signals, piercing through the cosmic fog and revealing galaxies that were once hidden from our view. Finding JADES-GS-z13-0 required staring at a single tiny patch of sky for hundreds of hours, collecting every single photon that arrived from the distant universe. Each photon that hit Webb's detectors began its journey when the universe was a baby, traveling across 13.4 billion years of expanding space, past billions of galaxies, stars, and planets, to finally reach us and tell its story. That is a miracle of science and a testament to human curiosity. You might wonder why this ancient, distant galaxy matters to us here on Earth, 13.4 billion light-years away. The answer is simple. We are made of stardust, and JADES-GS-z13-0 is one of the ancestors of every galaxy, every star, and every living thing in the universe today. The heavy elements that form our planet, our bodies, and the air we breathe were first forged in the cores of the first stars inside galaxies like this one. Without these early cosmic pioneers, there would be no sun, no Earth, no life. Studying JADES-GS-z13-0 is not just about learning about the early universe. It is about learning where we come from, how the cosmos built itself from a hot, featureless soup into the rich, complex universe we inhabit. It is about answering the most fundamental questions. How did galaxies form? How did light conquer darkness? How did the universe become the place we call home? Even though JADES-GS-z13-0 has since been surpassed by even older galaxies like JADES-GS-z14-0, discovered in 2024, it remains a landmark discovery that changed astronomy forever. It proved that Webb could deliver on its promise to unlock the universe's first moments, that our models of galaxy formation needed to be rewritten, and that there are countless more secrets waiting in the deepest darkness of space. Every time we look at this tiny red speck in Webb's images, we are not just seeing a galaxy. We are seeing the birth of everything. We are seeing the moment when darkness ended and light began, when the first bricks of the cosmic structure were laid, when the universe took its first breath and began to build the wonders we admire today. Please like, comment, share, and subscribe to the channel.